Can you see this one? The slide.
Yes, doctor, can see.
Oh, yeah. Okay, so for this fourth lecture, we will look into the modeling tool. It's called alternative set base. So when we look at the previous lecture, when you construct the term document matrix, all the index are based on a single word or a single term, right? So there is no way you can capture the dependency of two word or three word that always come together. So in this modeling number 2, we will look into set base in which they take into consideration the dependency between two words or three words. Okay? So this is based on the set theory with a vectorial ranking. So the fundamental idea is we want to capture the mutual dependency among index terms. So for example, last time I mentioned about computer science, software engineering. So how do we capture this? How do we capture term dependency? This is important because most of our words always, you can follow the same pattern when you read through the sentence or the paragraph, right? So the approach that this set-based model is that they want to have like a group of terms, and then this group of terms is considered as the main index key or considered as one index key. So what you do, you group two or three words in one basket, and this basket become the key or the index of the document that we have. Okay, so term set is a concept used in place of the index term. So instead of using a single term, we use set of terms to describe the document. So for example, if you have keyword KA, KB, KN up to KN, so if you have all these keyword in your document, so this is considered as one term set, like a collection of keyword that you can use to describe the document. Okay, so only if all the index term described in the set term set occur in the document, then we can say that the set term exists in the document. So since we have T as our number of keyword, so we have the possibility to have 2 to the power of T number of term set that you have in your vocabulary. Okay, so let me show the example. For example, if we have 3 keywords in your dictionary, so the possibility for you to have different pattern will be 2 to the power of 3. So you will have empty set, or you have a single item, or you have 2 items together, or you have 3 items. Okay, so instead of using a single keyword, we use term set. So now we have term set 1 up to 8. Okay, term set 1 meaning that we can ignore this one because this is empty set. But what they try to do to emphasize here is that it depends on the number of keyword that you have in your vocabulary. So if you have keyword five keywords, so you have 2 to the power of 5 number of pattern that you need to consider. Okay, but this one, for example, if t grows up to 1,000, so the number of pattern that you have will be much bigger, right? Because you have to consider all pattern that you can generate based on the keyword that you have. So what happens is that they say, okay, why not we only look at the query, and based on the query, we generate the list. Okay, so for example, we have this 4 document. We will be using the same document here, and then we can define that T be the number of terms in the collection. That means you have T number of index term. So the number of pattern that you could get will be maximum this, right? The number of pattern. So that's why you have the number of term set that you could have will be up to 2 to the power of t. Okay. So for example, if we simplify this one using single keyword, then we have this set of document. Okay. So since we want to reduce the complexity of the competition, we will always look at the query first. We look at the query and we look at what are the symbol that we have. So for example, in this one, we have ABDN. Okay, ABDN. So how many possible pattern that we could generate from here? 2 to power of 4. And we have 16, right? Okay. So you generate last one. First, you use single term. So you use A, B, D, N, and this one will tell you the document containing this A, B, D, and N, right? Okay, now we look at two term. Okay, two term, and then A, B, and then another one is this A, D, and then next one will be A, N. Okay, but A, N, if you look at here, we do not have AN here. Let me bring this to the next page. Okay, so for this one, for AN we do not have. So first we work single and then double. So AB we have, and then AD we have, but we do not have AN, right? Because we do not have AN here. And then after that we follow by BD, and then we have BN, okay? And we're supposed to have DN again because we have DN here. Okay, so we're supposed to have DN, okay, in document 4. Okay, and then after that we combine this, become ABD, and then we combine this BD. Okay, so this one is similar to what we have here. So how many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So we stop here because we cannot generate more combination from here. That's why we start from the query. We start from the query and not from the document to generate the list. Okay, list set of terms. Okay. So once we get all of this, then the next move is we can reduce the term that we want to consider. Okay? So once we get all the term set, then okay, the way we generate the list of term set is we always look at a single term first, and then we go to second, third, and so on, and then we stop there. So the way we did just now is that we will start with the single term first. Okay, so when you start from a single term, for example, this one, A. So if this is considered frequent, no, let's suppose AD. So let's suppose this is frequent. We say that this one frequent if they exist in two documents. They exist in two documents. So the subset of this, which is A and D, should also be frequent. This and this. Okay. That's why when we generate the list later on, for example, like this. Okay. Let's suppose we say that the threshold or on the frequency of term set be 2. That means if they exist in two documents, that means they are frequent. Okay. Hold on 1 second. Okay, so let's go back to here. Can you see the slide? Term set.
Can, Doctor.
Okay, so this is our document. Okay, let's suppose we set the threshold of frequency to be 2, in which if that symbol or that term set exists in two documents, that means they are frequent. Okay, so we start with a single. This is our query, ABDN. So that means we will start with 4 one-term set. Okay, so when we compute the frequent one-term set, so we have ABD. Because A, B, D exists in two or more documents, but N only one. So over here, N only exists one time. So that means N is not frequent. Okay. So starting from the single one-term set, we combine AB, AD, and BD. Okay, from here, then we combine them. So we only can find AD and BD. For AB, okay, we're supposed to combine this one and this. So we look at the common document. So we only have this. So that means SAB is only document 1 only. So this is not frequent, so we remove them. Okay, and then we check again AD and then BD. Okay, so we have this. Okay, so from here we combine again. So when we combine this and this, we get what? ABD. Okay, but ABD, when you look at ABD, that always come together, so we can look at the common term. The common term will be only, no, the common document. So the common document is only 3. So that means your ABD, you only have document 4. Okay, no, document 1, sorry. So since we only have one document, so we say they are not frequent. Okay, so we stop there. So from this example, we only have 5 frequent term set. So we start with single, double, and triple. Okay, so in conclusion, we only have 5. So based on the process that we gone through just now, we start with 1 and then 2 and 3 and so on. So when we formalize the ranking computation, so we will have a query, and then we let this to be the pattern that can be generated based on the query. And then we have this as the number of documents which contain the term set I, and then N will be the total number of overall collection, and then F will be the frequent term set. Okay, so instead of looking at the frequent index, we are looking at frequent term set. So if you look at the formula is more or less the same. So this is your frequent term set, and this is your the number of document containing the frequent term set that we have. So the weightage will depend on these two, which is the the frequency of the term set and also the number of document containing the term set. Okay. So now let's take a look at how do we compute the weightage for each of the term set that we have. Okay. So always be careful with the weightage here. Okay, so we have two parts, which is the query and also the document. Okay, so the weightage for each of the symbol that we have or each of the term set that we have in the document will highly depends on where you getting them from. Okay, so we have two parts. So for this example, we are looking at the weightage of all the term set from document 1. Okay, so first we look at A, then how many times A exists? 1, 2, 3, 4. Then we have 4 here. And then this one will tell you how many document containing term set A. So we have 1 and 2. So that's why we got 2 and we get the 4.75. Okay. And remember that how we generate the list here. So this is your list of term set. So this is coming back from the previous one. Okay. So since we have we have 4 symbol, so the number of term set that can be generated will be 16, but based on our workout just now, we have 11. Okay, so we have 11. So each one of them we will compute. So this one, the single term set, quite easy, but what if this one? So AB, so we have, now we are looking at the occurrence of AB. So 1 and 2. And then AB, that's why we have 2 here. Okay. So the document that consists AB is only this one. So that's why we have 1. Then we can compute this. Okay. So what about ABD? So ABD, we look at the occurrence of ABD. So we take A, B, and D, and normal. Okay. So we can have this one as, but in document 1, ABD, ABD, we also have this one, A, B, D. Okay, so the order doesn't matter, but the composition of the term set must be the same, but you cannot repeat the symbol that you have taken. So in this case, we have ABD, so different set. So we also have ABD, another set. So we can form 2 times only. So for that one, we have 2, and ABD only consists in here. So 1 only. Then you can compute this. Okay. So this is the weightage of all the term set in document 1. So what you need to do is you need to compute again the weightage of all this in the query, because when we perform the ranking, remember last time we are looking at the vector format for each of the document, also the query. So we must also compute the weightage of each of the term set in the query, because then we can use the cosine function in order to compute the similarity. So how do we compute the weightage for term set in query? Okay, so again, in the previous exercise, we also need to normalize. So we will look into the length of the document. So for the length of document, we are looking at the only the term set or the keyword use. So since our Q is ABDN, so we only consider ABDN. So this is the length of the document. Okay. So, okay, now this is the weightage of the term set in document 1. So we want to compute the term set in the query. So this is okay. So we have 7 of them. Okay, for the next one. Okay, so this one is the weightage of A in the query. So A only exists 1 time, and then this is the same as the previous one, which is this one. So the weightage is 1.58. So we will do the same computation for BD. Okay, for example, for this AB exists 1 time, so that's why you get 1 here, and this is follow from here. So quite straightforward. So what the way we compute the weightage of the term set and the Q, we only compute the one that we where you do not have 0 here, because in the computation we will multiply with this. So if this is 0, there is no use of computing them here. Okay. So this is the weightage of all the term set in the query. Okay. So when we do the ranking computation, so we just take all the 7 terms, and then we divide by the length of the document, then we get this. Okay. Any question? So this is the computation is quite tedious, but you need to be careful. Okay. Any question? Okay. So if we look at the list that we have here, okay. So some of them, for example, A, B, D, this A, B, D, this is subset of this, right? So what they want to do is they say, why not we combine them? So if we have ABD at the bottom here, that's already considered. If this is frequent, that means the subset of ABD will also be frequent, right? So we don't have to consider this. Okay. So they introduced the closed term set. So in the closed term set, they says that all the subset of the frequent term set should also be frequent, given that the term set is frequent. So this is to reduce the calculation. So they use the concept of closure. So the closure of a term set, Si, is the set of all the frequent term set that co-occur with the term set in the same set of document. Okay, so for example, they said, okay, given the document that we have in our set of document, so if that term set exists in this document and they are frequent, so that means that term set occur in all the document in the document itself only. Okay? So if we formalize, we are saying that okay, we should not have, okay, this is not exist. We should have this which is not exist in which this is a subset of this is what a bigger composition such that you punya closed term set is a subset of this. So that means if we say this is closed term set, it will satisfy that any subset of this will not be considered anymore. Okay, for example, like this, this is single, okay, this is okay. But if we have BD, so that means we don't need to consider this because this is a subset of BD, so we only consider BD. And this one also, we don't consider A because this is part of AD, so the closed term set is AD, and then this one GH, GH, and GHT, so we only take the big one. So by having this, then we only consider the calculation for the closed term set here. So the objective is to reduce the calculation. Okay. So we go back to this example again. So let's suppose this is our condition. Okay. So this is our condition, our Q. So how do we generate this term set is that we look at this document. And the same pattern is this one, right? So when we combine this and this, then we get this. So the term set is AD lah. So we always look at the document first. So which one? So this one is this partner with this. Okay. So we have B and BD. So we have this one. Okay, this one is single. Dia sendiri. So D go to D lah. And then we have D4. D4 we have N. We have BN and BDN, right? Which is not considered here. Oh, yep, not considered here because N does not exist in here. So we don't consider that one. So this is out. And last one is this with this one. So which is AB and ABD. AB, no, ABD. AB and ABD, then you get ABD. So this is the reverse of this. This is the reverse of this. This is the reverse of this. Okay. So this is all the term set, closed term set. So we have reduced from this two become one and so on. So we have simplified which one that we need to consider. So our final term set will be D, BD, AD, and ABD for this situation only. For this situation, for D only, D1 and Q. Okay. So instead of 7 just now, so we only take 4. So we take D, we take ABD, we take AD, and then BD. Okay. So divide by 7.3. Okay. Any question? Okay, so the calculation is reduced because before we find the term set, the calculation is this one, 7. And after that, we reduce because we use the closed term set, so we only consider 4. Okay. Okay, we can further reduce this by having this situation. For example, if we have a threshold for the frequent term set, we say that only 2 documents, 2 or more. So that means we will not consider D4, D1, and so on because all these term set only exist in one document. So we don't care about this. So what left is we have this 5. So this 5 we combine with this, and then this one combined with this one, and this one alone. So basically we have 3 only. Okay. So this is implying that the threshold for the frequent term set is 2, and also we using closed term set. So at the end, we only have 3 term set that we use to calculate. Okay. Any question? Okay. So that's the purpose of having this closed term set is to we restrict the ranking competition to closed term set only, and it will reduce the query time. Okay. Any question? Okay, let's go through this one, a simple one. Okay, so how do we start? But we need to look at the what information given to us. Okay, so for this one we have query to be BL. So BL, that means we have the pattern BL and BL. Okay, but it says minimum frequency threshold is 3. So B, how many document we have? D1, D2, and D3. Okay, so this is okay. L, we only have D4. Okay, and this one we have D4. Okay, because of this, then we will not consider this and this. So we only have B. So by setting the frequency threshold to bigger number, then what we have is we only have this B. Okay. So for the B, then in order to compute the ranking, so we need to measure the weightage of B in document 4 and also the weightage of B in the query. Okay, so the weightage of B in document 4 will be, we have 4 or 3, okay, 3, and then B exists in 1, 2, 3, so we have 3 here. But in the query, we exist 1, and this is the same. Okay, so this is what we get. Okay, so the length of D4 will be what? B, we use BL only. No? It's supposed to be B. Yeah, because this is all the word, not the term that we have in. Do we have M? Yes, we do have M. For reference. Okay. Okay, so the length of D4 will be B, because we have B, L, M, and then N, and then D. But we need to compute the weightage of B, L, M, N, and D. Okay. So this is the weightage of B, L, M, N, and D. So this one is number of occurrence of the term set B, and then L, M, and D. Okay. So once we get the length of D4, then we put that back here. Okay. So for this one, this one will be your second part of the project lah. Okay. So what I will do, you need to finish the project number 1 first. Okay, I will describe the project number 1 in I remember last time I put, like I said, 2 weeks, but I think you need more time for that one. Okay, so I will officially post the project part number 1 and number 2, so divide them into 2 parts and set the due date to be 3 to 4 weeks. Okay, any question?
Excuse me, doctor. Some students got out and they asked if we could admit them to their waiting.
Sorry, I cannot hear you clearly.